I'm University of Illinois Extension's Todd Gleason. Welcome to our webinar. Biofuels policy can seem a bit like a Goldilocks situation. Expanding biofuels too rapidly, well, that causes problems in our food system. But sticking with the status quo leaves us with the problems caused by our oil-powered transportation system. Now, in order to navigate a smart path toward better biofuels, it's critical that the clean fuels policy we have in place are implemented carefully. So the challenge facing policymakers is how to navigate a middle course that moves forward but is sensible and informed by smart analysis. Today I'm joined by several policy experts for what we hope will be the beginning of a broader dialogue with scientists and engineers on the futures of biofuels in America. We have a list of topics, some questions to cover based on feedback we received from you, our attendees, and we'll address additional questions later in the session. If you'd like to submit a question for our panelists now or at any time throughout the session, please do email me. My email address is tgleason@illinois.edu. Again, that address is tgleason@illinois.edu. If you're watching on our Will Ag site, you'll find that just above the YouTube video. Of course, you don't see me. I'm off camera, but let's take a moment to introduce the folks that are on camera this morning. From the Union of Concerned Scientists, Senior Scientist Jeremy Martin is here. Daryl Good from the University of Illinois, ag economist, and Scott Irwin, also an ag economist at the University of Illinois. Jeremy Martin, why don't you take some time and introduce yourself, please?
Great, thanks. Well, I'm from the Clean Vehicles program at the Union of Concerned Scientists. And our goal in the Clean Vehicles program is to cut oil use and to cut carbon emissions from transportation. And our analysis tells us that we can cut our oil use in half in 20 years if we move forward aggressively on a combination of measures to improve the efficiency across all of our uses of oil, but also to introduce new, innovative, cleaner fuels, whether that's electricity in electric vehicles or next-generation biofuels, which, of course, we're going to talk about today. And if we do that, if we cut our oil use, of course, we cut all the problems that oil causes for our economy, for the environment, for our security, and for the climate. Some of the questions pertain to other oil-saving solutions outside of biofuels, and I think it is important that we need we're not going to solve the problems of oil with one approach, just with biofuels. But today we're going to focus on biofuels, and in other webinars we'll talk about other topics. And when we're talking about biofuels, this is, I think, the place to talk about them. The University of Illinois is really right where the action is. Of course, as I arrived, I saw corn being harvested. This is the center of the Corn Belt. And it's also where people are working on miscanthus and future biofuels, the technology, the economics, the policy, and lots of things. And on the policy side, it's also where some of the policy makers in the Illinois delegation, Senator Durbin, Congressman Shimkus, other members of the Illinois delegation are kind of the key players in the biofuels policy arena. And as we said, when we're thinking about implementing this policy in a smart way based on sound analysis, these are the guys that I rely on to understand the implications of the RFS, the guys at Farm Doc Daily, University of Illinois. So I'm really excited to be here and participate in this conversation.
Thank you so much, Jeremy. Well, a couple of the folks that are sitting with us are from the Farm Doc Daily team, and you can find much more information from the University of Illinois on biofuels on the Farm Doc Daily website. The address, of course, farmdocdaily.illinois.edu. One of the primary authors is Scott Irwin. He's also an ag economist at the U of I. Scott, why don't you introduce yourself, please?
Well, I am an agricultural economist here at the University of Illinois, interested in commodity markets and agriculture kind of broadly defined, basically what I call Corn Belt farm economics. And of course, in recent years, issues surrounding biofuels and the renewable fuel standards has been a big part of the economics of Corn Belt agriculture, and that's my interest.
And Daryl Good is with us, a commodity market specialist at the U of I. Daryl?
Thank you, Todd. My career here at the U of I has primarily focused on commodity markets, primarily corn and soybeans, since those are the focus of production here in Illinois, and a look at all of the factors that tend to influence the price of those commodities, the production, the demand, and certainly in recent years, biofuels has become one of the more important factors in influencing supply and price of corn and soybeans, and that's my major interest, is how that policy and the resulting consumption of biofuels impacts our agricultural markets.
Well, let's start our first question, actually, Daryl, with you. Much of the attention on renewable fuels and the standard has focused on the impact on corn prices. Is this trend likely to continue, do you think? And does it depend much on EPA decisions, actually, the price of corn?
You're right. I mean, to date, corn-based ethanol has been the primary biofuel that's been produced and consumed. We've consumed as much as 5 billion bushels of corn per year in making ethanol for the domestic and export market. As the mandates have increased over time, requiring more ethanol, obviously that's pushed the consumption of corn up. It now appears that we're probably plateauing a bit in that scenario. And it does, I think, hinge a lot on EPA decisions in terms of how to enforce the mandate. Those mandates for renewable biofuels, or at least the implied mandate, the total minus the advance, would push us to 15 billion gallons by 2015. And how aggressively we pursue that objective, I think, will determine how rapidly we increase corn consumption. But clearly the major growth is behind us at this point, and the near term we are plateauing corn consumption.
Scott Irwin, can you explain both the mandate and what it means for ethanol and the blend wall and what it means for ethanol as it currently stands in Washington, D.C.?
Okay. Well, let's start with the mandate. And Todd, help me remember, I'm getting older if I forget part of your question.
Sure.
The mandates are part of federal legislation that's popularly known as the Renewable Fuel Standards. And they are volumetric minimums of different categories of biofuels that must be blended and used in our domestic fuel supply. For example, Daryl just mentioned that there are targets that are minimums for renewable fuels, which have almost exclusively been in the form of corn-based ethanol, that rise to 15 billion gallons by 2015. And then, so there's sub-mandates for different kinds of biofuels, and then an overall total. And that total is scheduled to go up to 36 billion gallons by 2022. So I think the key for people that may not be familiar with the RFS is that these are not voluntary guidelines. They are, in fact, statutory minimums for which there are civil penalties if the parties obligated under the renewable fuel standards do not comply. So it's the law of the land, literally. And I think the second part of your question was
related to the blend wall.
The blend wall. And so the blend wall, simply put, is an issue where until very recently, U.S. regulations only allowed gasoline blends to contain up to 10% ethanol by volume. And as our mandates have increased over time, they have begun to collide with that blend wall. Just as a simple example, if we're consuming 130 billion gallons of gasoline transportation fuel in the U.S., and you can only put 10% of that in the form of ethanol, then the blend wall is a physical 13 billion gallons.
Jeremy, can we talk about sugar ethanol with you just a bit?
Sure.
Okay, so most life cycle analysis suggests sugarcane ethanol has lower greenhouse gas emission than corn ethanol. And the RFS has an advanced biofuel category that includes sugar ethanol. It also excludes, actually, corn ethanol. It's the only fuel source that would be excluded in the advanced. But sugarcane ethanol is subject to the same blending constraints that corn is. How does the advanced biofuel mandate in the U.S. affect U.S. agricultural markets and its fuel mix?
Sure. Well, let's start. So sugarcane ethanol, according to pretty much all the analysis, has a lower carbon emissions than corn ethanol. And, you know, sugarcane is a very productive plant. It's readily converted into fuel, and they do that without a lot of fossil fuels in the process. And that's some of the reasons that the life cycle analysis for sugarcane looks especially good. When you think about, that seems positive, but if you think about the implications, in the next year or so of dramatically increasing the use of sugarcane ethanol in the United States, it sort of collides with this blend wall, and it can lead to some strange outcomes in trade. For one thing, in the last few years, Brazil's been struggling to produce enough ethanol for their own use in their own automobile fleet. And so if the U.S. started to import very rapidly large amounts of sugarcane ethanol, the Brazilians would sort of either need to gradually switch their fleet back over towards gasoline, or they'd need to import a lot of corn ethanol from the United States, because we're really the only other very large producer. And so neither of those outcomes, sort of we use their ethanol, they use oil, or we use their ethanol, they use our ethanol. Neither of those is really accomplishing the goals of the renewable fuel standard, and it's also not supporting the growth of a domestic advanced biofuels industry. And so for that reason, this is one of the areas where I think the EPA needs to be really careful and really look at the kind of the agricultural economics, the impact on trade, of different paths they could take in administering the policy, to make sure that they avoid counterproductive outcomes and really focus on, making sure the policy delivers the goals it was intended to deliver, reducing oil use, reducing greenhouse gas emissions, and also supporting the development of an advanced biofuels industry.
One of the paths, of course, that they could take would be to remove the exclusion for corn for the advanced biofuels. Would that be an acceptable path?
Well, I think there's one thing, actually, I'm glad you brought that up. There's a specific exclusion for corn ethanol, but the main thing is actually the greenhouse gas standard. To be an advanced biofuel requires a 50% reduction in greenhouse gas emissions compared to gasoline. And for the most part, corn ethanol, as it's produced in the U.S. today, won't qualify for that in any case. And so I think there's two elements of that. As far as the exclusion, there's a lot of pieces of this there's some pieces of the administration of this policy that are written into the law, and there are others that are at EPA's discretion. And it's quite clear that this piece is written into the law, and so it's not up to EPA to change that. That would require Congress changing the law. I guess I've been focused a lot on what EPA can do, because they actually have a great deal of flexibility and a great deal of discretion to move forward with the standard in a way that avoids problems and focuses on the goals. But that particular change isn't one that they have discretion over.
There is another biofuel that could come from farms in the Midwest, and does to some extent. That would be soy diesel. Does it meet the greenhouse gas standard?
Yes, EPA has found that soy biodiesel doesn't, and actually that sorghum, that ethanol produced from sorghum can, if it's produced in the right manner, with a minimum use of fossil fuel inputs, that it also can potentially qualify as an advanced biofuel. So the advanced biofuels are not only sugarcane ethanol. That's often emphasized because that's the one where there's current production of billions of gallons. But there's potential for other fuels as well, or biogas. There are other pathways for advanced biofuels besides corn and sugar.
Daryl, you have looked at soy diesel, its production and its potential increases, and those things that have already come about. What do you see in the future for biodiesel in the next 18 months?
I think for the most part, biodiesel production has been driven by the RFS mandate. Last year we had a minimum requirement of 1 billion gallons of biodiesel. This year at 1.28 billion gallons. So that has been the primary driver to meet that mandate, with I think somewhere between 50 and 60% of the feedstock for biodiesel coming from soybean oil. As we move forward, certainly the level of the mandate will continue to be an important component. of biodiesel production, whether that increases or not. Second will be the total advanced biofuel mandate and the resulting undifferentiated component of that, which biodiesel could fill along with primarily Brazilian sugarcane. And so it will be kind of on a physical blending basis, it will be kind of the relative economics of biodiesel versus imported sugarcane that would determine which product would meet that undifferentiated component. And then thirdly, depending on the total biofuels mandate and the size of the blend wall, it may not be possible for renewable fuels, primarily corn-based ethanol, to meet the total renewable mandate, so that some of the advanced biofuels would have to be used to fill that gap. And so there's another opportunity for biodiesel. A number of factors will influence the rate of growth there, but I think the primary driver will be the total advanced mandate that EPA announces.
Scott, biodiesel production's not been nearly as tied up in the food versus fuel debate as corn ethanol. What's the difference there for biodiesel, and how does the use of biodiesel affect food markets, trade in vegetable oil and soybeans?
Well, that's a really interesting question, Todd. Of course, most directly, biodiesel, as Darrell mentioned, the main feedstock is soybean oil. And soybean oil is one of our main vegetable oils. So potentially that is pulling away a food for fuel. Probably why it hasn't risen as high on the public policy agenda is that, at least here in the U.S., the use of soybean oil as the main feedstock for biodiesel, it just hasn't been large enough relative to the market size to have the kind of potential price impacts as compared to corn ethanol. That's not necessarily true if you move across the Atlantic to Europe, where their biofuels mandates primarily in the area of biodiesel. The main impact on world markets in terms of linkages is basically if you pull soybean oil into biodiesel production, something else has to probably come into play to fill that gap. And more than likely, it's other kinds of vegetable oils and things like palm oil. And so that's probably been a part of increases in those sources of vegetable oils in recent years as they've kind of filled the gap. But to date, again, at least here in the United States, it's not been a major food versus fuel issue because it hasn't been as large of a draw.
You know, Jeremy, you've drawn this link between soybean biodiesel use in the U.S. and palm oil production. In your view, deforestation, some carbon emissions in Southeast Asia. How does that link work, and what factors influence whether this link is important or not?
Yeah. Well, as Scott said, as soybean oil leaves the food market and enters the fuel market, then it does create a hole. We looked over the last few years at the sort of the production patterns, and we haven't seen vegetable oil production rising to in the U.S. rising to supply the extra vegetable oil. We've seen changes in the trade pattern, so reduced exports, increased imports of vegetable oils. And it's not that the U.S. is necessarily consuming a lot of palm oil itself, but if you look, at the other side of the trade equation, if you look at who else is exporting vegetable oil, and what's the fastest growing, and so palm oil is the fastest growing, cheapest source of vegetable oil, and it's the one which is decoupled from the production of meal, from protein meal. And so, that's a big concern because palm oil is, the expansion of palm oil is happening in these peat forests in Southeast Asia, and as those forests are cut down, there's enormous carbon emissions, and so it's pretty clear that expanding the market for palm oil is not a way to reduce the carbon emissions of transportation. But the linkage probably depends on what do consumers in other parts of the world do when soybean oil price increases. Do they switch to palm oil? Do they switch to another oil? And how much? How does that all shake out? So it's definitely something that we're concerned about. And whether it's important, whether really depends on how big the draw is into the biodiesel markets. And so I think it's another instance where if we move this policy forward sort of prudently, with an eye to what are the underlying impacts on commodity markets and trade, then we should be able to mitigate and to avoid these bad outcomes. But if the policy sort of rushes forward beyond where the resources are available to support it, then we can have problems.
We've taken up corn, soybeans, sugarcane, sorghum, palm oil. There are a couple of other things on the cellulosic side that we've been working on at the University of Illinois and other places, Scott. And I'm wondering how far along we are towards cellulosic ethanol. I believe there are a couple of plants in operation at this point. And whether we can manage that, and then whether the grasses, for instance, miscanthus, switchgrass that have been looked at, are viable options.
I guess there's probably two ways to answer that question. We've actually seen some real strides towards commercialization of cellulosic technology with these plants opening up, at least several on a commercial scale. But on the other side, the scale of the expansion in cellulosic production is nowhere near what was hoped for 5 or 6 years ago when the renewable fuel standards were first instituted. For example, in 2013, I believe we were supposed to have this year 1 billion gallons of cellulosic, and there's even argument over whether it'll be as high as 6 or 8 million gallons. So it gives you a sense of the scale of the difference between what's actually happening in the marketplace and what was expected a few years ago. There's certainly a lot of development and research, but as of yet, it still hasn't hit a real commercial liftoff phase yet. Maybe Jeremy might want to jump in on that.
Sure. Yes, it's definitely true that the timing of the kind of commercialization and scale up has been quite a bit slower than was anticipated or hoped for. Although I definitely prefer to look at the cup as half half full. I think the fact that we're starting the commercial production is important. There's a lot of things that you sort of learn when you start running something at commercial scale that you just you can't learn. And so it would have been great if we started 3 years ago, but I'm glad we're starting now. I guess, yeah, go ahead.
Can I ask, does it make a difference to you that when we start this process that it's corn stover and not
the perennial grasses?
Perennial grass?
Yeah. Well, perennial grasses definitely have a lot of environmental benefits that make them a very attractive feedstock. And when you look at the, we did a kind of an assessment of how much biomass, and the Department of Energy, other people have done this assessment. If you try to figure out how could we really make tens of billions of gallons, you really need the perennial grasses to get there. But the fact is, it's a lot easier to figure out how to develop a supply chain, and because the corn stover is already there, because it's already on the same field where there's a tractor, it's in the same county where there's an ethanol facility, and so there's a lot of practical reasons why I think it makes sense to start out with the corn stover. And really what you need to do is you need to develop the technology to make biomass into fuel, and then you also need to develop all the the technologies or the practices to grow and market the perennial crops. And so I think some of the perennial crops we're seeing that people are starting to work on, they may be entering markets for biomass, they may be entering pellet markets, and so I think it makes sense to me that we start the cellulosic biofuel technology with the feedstocks that we have, and then try to bring up the perennials at the same time.
So do we do that through ag policy or energy policy?
Well, I think definitely we need both. A lot of the benefits of the perennial grass cellulosic biofuels there's benefits that show up in the life cycle of the fuel because they store carbon in the soil, because they can be converted into fuel without a lot of fossil energy inputs. You get a good score, a kind of life cycle. The life cycle of the fuel looks good, but a lot of the benefits are, that you can reduce erosion, you can enhance the long-term fertility of soil because of the carbon stored in the soil. You can reduce water pollution. So there's a lot of benefits of perennial grasses, and in fact, we use a lot of perennial grasses in agricultural policy, in conservation, in stream buffers, and to serve environmental goals. And so the idea here is that we can enhance the economic competitiveness of a crop which has benefits on both the fuel side and the ag side. But for that all to work, and it's some distance still for it all to come together, you're going to need good policies on both the energy side and the ag side.
Well, let's move to the role of policy in government. EPA and USDA both have important roles to play, as we already know, in ensuring that biofuels policy achieves the stated goals, reducing oil use, curbing climate emissions, driving the rural ag economy, without creating problems in existing markets or causing more environmental harm than good. That last part may be less debatable than others, or more debatable than others, but it happens. What criteria should be at the heart of EPA's process to move the renewable fuels policy forward, in your opinion? We'll start with you, Jeremy.
I think one of the important factors is really to look at what are the impacts on the markets, and EPA has a lot of flexibility in how they move forward with the renewable fuel standard, and they should evaluate different options and then look to experts around the country to sort of figure out what are the implications for trade, what are the implications for commodity markets, what are the implications also on the infrastructure side. What can the infrastructure manage, and make a decision which keeps us moving forward, reducing oil use, reducing greenhouse gas emissions from transportation, but does so in a pragmatic way, because we're not going to solve this problem by 2015. This is a problem we're going to need to be at for quite a while, and so we're going to need stable policies. And I think stability requires some discretion, especially in the next couple of years.
I really like to borrow a term from Jeremy of we need smart policies. And, that would be, there's clearly a lot of optimism in the United States and lots of places about our potential to increase crude oil and natural gas production. Looks very positive, but it would seem to be prudent to also continue making some investments in alternative energy sources. And so the question is how to do that in a way that we're willing to have flexibility. So when I say smart, I really mean flexibility. For example, we're running into the blend wall issues in implementing the RFS. Unfortunately, there wasn't anything really explicitly built into the statutes that kind of would go into place automatically when we started running into those barriers and problems.
Well, weren't the RINs put into the marketplace in order to help alleviate that problem, or the renewable identification numbers for the ethanol gallons?
Well, they were there, as I like to say, to kind of be the grease in the system, to deal with kind of the frictions of people who had different business models in different places in the gasoline and diesel supply chain, so that they could kind of trade out of their obligations at low cost. But that system, I'd argue, didn't really ever, it was never really designed to deal with a situation where you have a hard collision between the mandates and a blend wall, and then you get those credits, in essence, the lubrication for the system become really, really expensive. And so now we're struggling to deal with that.
We're dealing with that, and we're looking forward to next year, an US EPA, an elite document, may or may not change the RFS. Have you thought about what that means for the corn market, the potential for other forms of ethanol, E85 in particular, to make their way into the marketplace?
Well, the leak document that most of us have been looking at would put the total total renewable fuels, biofuels mandate at 15.2 billion gallons, with 2.2 billion basically advanced, and the implied renewable component would be 13 billion gallons, again, primarily corn-based ethanol. So the impact on the corn market, I think, depends a bit on whether you evaluate that with respect to where we are or where we would go without a change in the RFS. We're currently consuming and producing somewhere around 13 billion gallons of corn-based ethanol annually. So a mandate at 13 billion would be basically status quo with what we're doing right now. But certainly, as in the statutes, the mandate for renewables would continue to increase up towards 15 billion gallons, and if that was implemented, would imply perhaps a stronger demand base for corn. So relative to where we could go, it says we're backing off a little bit, but it says we hold the ground that we've gained in terms of corn used for ethanol production.
Does it affect the price of corn very much?
In the short run, I don't think it does, because it doesn't change what we're doing right now. Perhaps. I think one of the biggest issues, depending on where the EPA ends up, we do have this stocks of RINs that we've accumulated that can be used to meet some of the mandate going forward. So if the mandate is now reduced below what it would have been, what will obligated parties choose to do? Will they use the RINs to meet part of the even lower mandate, or will they continue to choose to hold those to manage uncertainty in the future? To the extent that they choose to use them now, then would reduce the physical blending requirements and the amount of corn we would use for ethanol production. So, and then you add to that a bit of uncertainty about the trade of ethanol. Has pretty strong implications for how much ethanol we need to produce domestically. Do we have a net export balance of ethanol, or is it a net import? Makes a lot of difference.
You watch, Darrell Good, the distribution of food and fuel supplies across the planet, whether it's agricultural energies, crude oil, agricultural energies in the form of feed. What's your view about the way this moves around the planet and the difference that biofuels makes in the available supply?
That's a pretty broad question, as you recognize. What it does, obviously, is have, I think, differential short-term and intermediate-term impacts. In the short run, what we have experienced is kind of a structural change on the demand side, so that we see prices initially move higher, particularly for corn, in response to that structural change on the demand side. And then there's an opportunity in the longer term for a supply response to that. And I think that's what we've been experiencing in the last 2 or 3 years is that supply response part. And we have seen a fairly substantial increase in crop production, particularly corn production, around the world, as prices have been relatively high. So it does filter through the entire globe, and it eventually results in some newer equilibrium of production and consumption of the major commodities.
Jeremy, how do you view E85?
I think the E85 is an important question in the EPA, its determination over the next year. And the term, the blend wall gets used a lot, but really, I actually think that maybe the right way to think about it is some pretty aggressive speed bumps, in the road. If we try to continue to expand ethanol use, at the rate that we have been, there's some real infrastructure bottlenecks, not to mention the impact on the underlying commodity markets for corn and for crops that compete with corn. But there are more than 10 million flexible vehicles on the road, and the mechanism of of the RFS, the RIN prices, can make E85 economically attractive in a way that it hasn't been for the last few years, or actually for most of its history. And so, so I think that the question of exactly how much E85 gets used in the next year or so is going to be an important development, and one that I'm kind of looking to the experts here to help me understand, because I do think when we're looking at these speed bumps on the path of biofuels, and the kind of the expectation that we'd get to 36 billion gallons in 2022 looks unrealistic. So I think I think people who've looked in some detail, some analysts would say that pace isn't going to work. We're not going to make it there, and if you try to make it there, all sorts of strange and counterproductive outcomes happen. In fact, most of the ag forecasters or the energy forecasters have stopped using 36 billion gallons by 2022 as a basic scenario for a forecast, because it just doesn't look plausible. So we are going to have to slow down, and so the exact question is how aggressively do we slow down, and how do we approach these speed bumps? I think we need better alternatives to oil. We have a lot of opportunities over the longer term with advanced biofuels, and so we want to keep moving. And so it's really a matter of calibrating these speed bumps and figuring out how do we keep moving forward, but avoid some unproductive outcomes that would come from going too fast.
Well, let's transition to the last question before we move to questions from the listening and watching audience. And I don't know that each of you will want to answer this, but how would you advise Congress to move forward on the RFS at this point?
Well, I think that Congress wrote the Renewable Fuel Standard back in 2007, and they really gave EPA a great deal of flexibility, and in particular, they gave them a lot of flexibility sort of for the second half of the policy starting now. And so I think that the EPA has the tools they need, and so Congress needs to focus now on oversight, which they've started. They've had some hearings, and I expect them to continue to look into the Renewable Fuel Standard. But I guess I'm looking for the primary activity over the next few months to be at the EPA in their administration, but also the EPA will certainly be getting input from other agencies, from the Department of Agriculture, from the Department of Energy, and so that's where I think the activity is headed now.
My main advice to Congress would be for some clarification. There's going to be quite a significant debate about whether the EPA truly has the statutory authority to write down the renewable mandate as apparently they're going to propose based on these leaked rules. And it's a part of a general issue of what kind of smart flexibility does Congress want written into these kinds of volumetric standards when something unforeseen happens. And I think that that's the kind of clarification and some more built-in flexibility that could help make these policies smarter.
So let's move on to some of the questions, and mostly we get comments and questions in the same process. Some have come in beforehand, some as we're doing this process. We have one here that says they were surprised to hear that soybean biodiesel was regarded as a green fuel. That soybean oil, they say, is a byproduct, so when it's bid away from the food and oil market, while the soybean meal market is satisfied, it is replaced with a food oil, palm oil. And this is mostly a comment that is grown on peat soils, of course, cleared in Indonesia and Malaysia and some of the rainforest, with enormous greenhouse gas releases. And so it goes back to this distribution, I think, question across the planet and how one thing substitutes for another.
Well, maybe I'll jump in. I mean, the different jurisdictions have approached these questions in different ways, and so in the EPA's administration of the Renewable Fuel Standard, soy biodiesel, is classified as an advanced biofuel, and this is a sort of a technical determination that's been made. In other jurisdictions, in California, they have a differentiation, and so biodiesel that's made from used cooking oil gets a preference, and you get more compliance value. So the market is encouraged to use more of these used cooking oils and to avoid, if they can, the first use vegetable oil. And the European Union, when they've looked at life cycle analysis of vegetable oils, they've been much more pessimistic about and really had a much stronger emphasis on the connections between different vegetable oils. So different analyses come to different conclusions, but as far as the EPA, they've got to work with the framework that they've got.
Another comment to follow up with this. This comes from the National Biodiesel Board. On the subject of international trade of vegetable oils, have you considered that the soybean oil used for biodiesel is stranded in the domestic market and does not substitute on the international market? First, is that a true comment? Do we know? And then secondly, the domestic crush of oil seeds is sized to meet the domestic demand for protein meal. That's probably true. Without biodiesel, domestic use of soybean oil does not match the quantity of oil production. So they go on to say major importers like China have demonstrated that they prefer to import whole beans, which we know. They desire the value-added crushing industry to reside within their borders, and from imported whole beans they satisfy their demand for protein meal and soybean oil. They do not wish to import soybean oil without the meal. I'm not quite sure where all of that lands, but wanted to follow up on that discussion for biodiesel just a bit.
I come to Illinois to talk to experts in these kinds of matters, because I'm an amateur on the economics of the soybean crush and things like that. I'll say that my read of the data has said that we are seeing a shift in the trade balance, kind of tracking the increased use of vegetable oil. But I think the important question is, it seems clear to me that at some point it's too much, and so the question is, I don't think EPA should rely just on my judgment. I think EPA needs to take an approach that looks at the economics and relies on expert judgment from agencies and from experts around the country to kind of figure out and calibrate a smart and kind of a sensible number that's not too much where it starts to have counterproductive effects, but does keep us moving forward. And so I definitely don't have all the answers. And
Jeremy, can you follow up on biofuels and crop production in general? The impact on the ecosystem, CO2 emissions, those sorts of things. I would guess that you and the Union of Concerned Scientists have looked at these a couple of times.
Well, definitely. I mean, that's one of the big concerns is that I think palm oil and especially the associated deforestation is a really counterproductive outcome. Expanding palm oil dramatically is not going to be a smart way to expand the biofuel production. But so, the question is, what's the amount of, how do all these things fit together? And it's pretty complicated. It takes relatively sophisticated analysis, but what I think we've seen is that, EPA is not afraid to do pretty sophisticated analysis, to consult with experts in agricultural economics and to look at models of global trade and to try to figure out and calibrate, what are sensible, what are the implications of different decisions they're going to make. And of course, they also rely on input from people like the Soybean Association and the Biodiesel Board, to try to understand, make sure they have the best data from all of the stakeholders.
Okay, some other biofuel sources, wood, I think here. Why don't we consider methanol?
Oh, methanol. Well, I mean, the fact is that the Renewable Fuel Standard is not, we've talked a lot about ethanol and biodiesel. Those are the predominant sources, but the Renewable Fuel Standard has equivalence values for different fuels. Now, methanol isn't a big player in the U.S. now. Using wood to make cellulosic biofuels, I think one of the...
And am I correct that methanol is derived from wood? I want to make sure that I've got that right. I don't recall correctly.
Methanol is, historically, there have been paths to make methanol into wood. but
From wood, yes.
there's I mean, I'm a chemist by training, and there's different molecules we can use for fuel. And methanol's one. And then you can make methanol into dimethyl ether, which you can use as a fuel. Of course, we can use ethanol and biodiesel as fuels. There's other fuels. There's drop-in biofuels where they chemically look like gasoline or diesel, but they could be made from wood. They could be made from soybean oil. They could be made from sugar. There's different chemical and biological processes. And so, on the one hand, there's, pros and cons to different fuels, but the RFS is actually pretty flexible in that regard. If you make butanol instead of ethanol, you get 1.3 gallons of ethanol credit per gallon of butanol because of the different energy in those. And so the same would apply to any other fuel. And then in terms of what's eligible for different, if it's eligible as an advanced biofuel or a conventional biofuel, that depends on the life cycle emissions. And so that's an assessment that that's heavily influenced by, by what's the source and what's the, what does it take to grow the crop or whatever, and then how much fossil energy, what are the inputs when you convert that source into a fuel. So it's the policy framework is pretty flexible about which molecules enter the marketplace, but there are some real constraints in terms of what the vehicles are equipped to handle, what the marketing kind of apparatus is equipped to deliver. And in the U.S., methanol isn't a big player. I think it's maybe more so in some other countries.
And we have ag economist and a chemist with us, but there are some folks that want to know about some other things, and maybe you can answer some of these questions. What's being done to increase production of agricultural crops to allow for increased production of biofuels? Has anybody been working on biofuel-specific crops for corn, soybeans?
I mean, arguably these energy crops like miscanthus that are being developed just across the way here at the Energy Biosciences Institute. I think there's a whole kind of miscanthus institute, right?
Correct.
I think the primary target of those is as sources of energy, either I think for liquid transportation fuel especially, but potentially also for other for thermal or electrical power, thermal energy or electrical power. So I think those are crops that are being developed exactly for that reason. And there's a kind of an interesting debate about, some of those have potentially very high yields, and they also, fit a slightly different niche in the agricultural marketplace or landscape. So, I think there's a lot of interesting work going on. And I think on the other experts here at University of Illinois looking at, what are the pros and cons of the different crops, and what advantages do you get from perennials, and where would you plant them in a way to get the maximum advantage, whether it's sort of in a rotation or where in a field, or what type of soil. So a lot of different work in that regard.
I think also in a bigger picture, say as we use increasing amounts of our traditional crops for biofuels, I mean we do have ongoing efforts to increase the total productivity of those crops so that yield per acre continues to go up, and that kind of technological work is important to help fill the gap, if you will, between total production and what is used for biofuels. Also work going on in terms of, for example, corn for ethanol, altering the starch content of some corn in order to increase the productivity. And so there's efforts on a lot of different fronts, I think, to accommodate crop production and increased biofuels production.
Can Scott, you and Daryl maybe talk about the adoption of energy crops or crops in general, how that happens across the planet, what kind of incentives need to be put in place, if any, for a producer to adopt a crop that they're not used to? And we might go all the way back to soybeans as it was introduced into the United States, I think in the late 1930s and early 1940s.
Well, historically, you find that there's always efforts to find new uses, new crops to bolster farm incomes, and only a few have been successful historically, and in the long run, those have been driven by market forces. For example, soybeans, driven primarily by the demand for high-protein animal feed supplements. And so I think that that's the main driving force in the long run. But that has also tended over time to be really supplemented by kind of basic public research in terms of breeding, extension programs to assist farmers in understanding the economics and the agronomics of how to grow these crops. So there is a real element of public-private partnership in getting these things off the ground. And wouldn't be a big surprise if in particular examples of energy crops, it would be similar model.
And it would work in what ways?
I think coming back to an earlier question, I mean that the policy on biofuels can create some incentive and some market for these cellulosic crops, but farmers are going to need to. We're going to need special strains that are developed and optimized to be efficient in that regard. We're going to need the conversion processes, and we're going to need a lot of I think work from extension services and to sort of figure out how to grow them in a way that makes economic sense for farmers and all of that. And I mean that's the kind of work of the land grant universities that they've done over time, and I think that's what I think that's how this model can work over time. It's not going to be the renewable fuel standard alone isn't going to get us there. It's going to be a combination of policies and contributions from all over the place.
Here's an interesting question that had just arrived. It says, if I had a pile of miscanthus, other biofuel mass or biomass in front of me for energy, why would I go through the thermodynamic hoops to make it a liquid fuel instead of just putting it into the boiler and burning it?
Yeah, that's an interesting question. I mean, I think that in the short term, there have been some analyses which say, why not just generate electricity using the biomass, and don't we, if we're displacing coal, don't we get a bigger benefit in that regard? But what I think, if you take a slightly longer term perspective, we have a number of relatively low cost ways to generate a low carbon electricity, and liquid transportation fuels are more difficult to replace with low carbon sources. And so, I think that's where, in the long term, the question is, if you have lots of good options to reduce the carbon intensity of electricity, then the benefits of adding another one in these energy crops are limited, and in the liquid transportation fuels, there's a big role for electrification. I think if we take a step back and say, how are we going to reduce the carbon intensity of transportation? We can definitely do that with efficiency. We can definitely do that with electric vehicles, but those solutions alone won't get us where we need to go. And so there's going to remain a key role for energy-dense liquid transportation fuels. And so I think in the long term, that's why we need cellulosic biofuels and why it makes sense to put miscanthus into a liquid fuel. But it's also going to take a while till we can expand that industry to scale. And so I think right now, people who are growing miscanthus may be turning it into pellets, using it in place of other fiber. And that makes a lot of sense right now. But as we have a 20 and 40 year time horizon, there's an important place for it.
Our hour has gone quickly. Time to wrap things up and to have a final word from each of you about biofuels, the reformulated fuels standard, and what you might see in the future. And I guess we can start with you, Scott Irwin.
Mm-hmm. I think the most interesting question on the horizon is basically, was it Congress's intent to basically incent or stretch our fuel system, if some people would say force in some early development of renewable biofuels, and the speed bump, as Jeremy says, like something like the E10 blend wall, is just something that we'll need to work around and get our and work through, or is that a wall, truly a wall, that stops us where we're at today? And ultimately, that's a public policy question that through Congress, the voters of the United States have to decide.
Jeremy?
Well, this has been a really interesting and useful conversation for me, and I think there are some key decisions in the next couple of years about how to confront the short-term challenges with the RFS. I'm really focused on the longer term. How do we keep moving forward so that over 20 years and 40 years we can bring this next generation of biofuels to market. I guess I'd like to close by kind of taking a step back. I know when I saw some of the questions that came in, people always ask, what about electric vehicles? What about other solutions than biofuels? And I do think, if we're all thinking, how do we make progress on these goals? How do we cut oil use? How do we cut transportation emissions? I can't go to the gas station and say, fill it up with cellulosic biofuels today. So that can seem a little distant. But what I can do is make sure that I'm taking care of my vehicle so that it operates efficiently, that I'm not driving more than I need to. If I need to get a car, I can get an efficient car. So there's sort of near-term things that we can each do to cut oil use, and then there's long-term things that we can only do through the democratic process. That are also really important, and I think they all fit together to get us where we need to go in terms of cutting oil use and transportation emissions.
Any final word from you, Daryl?
Really not a lot to add. I think the take-home message right now in terms of what's happening with the EPA deliberations and so on is that this balance that Jeremy talks about is that, to meet the goals of the RFS, there needs to be a balance between what is doable in the short run and also a balance with motivating expansion and moving forward. So it's how hard do we press the accelerator, I think, is a real issue that we're trying to deal with right now.
Jeremy, how do folks get hold of you if they'd like to continue this conversation with you?
Yeah, that's a great point. Well, so first of all, if you go to the website, Union of Concerned Scientists, that's ucsusa.org. I guess most people who are watching this may already be aware of that. You can sign up to get so that we can keep you up to date in terms of both kind of practical things that we can do to cut oil use ourselves and sort of policy debates that are going on. People can email me directly at jmartin@ucsusa.org as well, and that shouldn't be hard to find on the website. But I think those are the ways to get in touch with me, and I'm looking forward to kind of continuing this conversation over the weeks and months ahead as this year's EPA process plays out, and the longer term debate shapes up.
And the Farm Doc Daily team does a great deal of work on biofuels, ethanol, soy diesel, and that can all be found on the Farm Doc Daily website at farmdocdaily.illinois.edu.
That's right, Todd.
And if they want to get hold of you, Scott, what's your email address?
It's SIRWIN, Serwin, all one word, at illinois.edu.
And Daryl, go ahead.
Yeah, email address is just d-good@illinois.edu.
Thank you all for joining us, and that wraps up our seminar. We appreciate you being with us. I'm University of Illinois Extension's Todd Gleason. Thanks to the Union of Concerned Scientists, to the Farm Doc Daily team, to the College of Agricultural, Consumer, and Environmental Sciences, and to the URL host of our programming, willag.org. That's willag.org. You can find me there as a farm broadcaster. You have a great afternoon.